Now that we have uploaded data and pre-processed it by creating phases and validating tags and jibes, it is time to start with the calibration process. So we get to this speedo calibration page where we are offered the possibility to look at the calibration of our speedos. So the way we look at the calibration is basically to compare the values that our speedo is reading out towards possibly a delta between the speedo reading and the speed over ground. And then in the second graph here, we can also evaluate what is the delta between the speedo and speed over ground in function of heel, because we do know, especially on monoholes, heel might have an effect on the flow alignment to the hole and thus the readings in the speedo. So the first thing to notice is that comparing speedo and speed over ground doesn't always make sense, because we know that one of the deltas that creeps in there may be the current. So for that reason, we can actually say, yes, we know there was current. So you might have had that in the log. It turns out we don't have that from the log. Or you can actually enter it manually here and say, well, overall in this portion of sailing, there's about 0.1 knot of speed of current heading south. So from then on, we see on this graph that we're no longer comparing speedo and speed over ground, but a speed over ground that has been corrected for current. So in theory, these should match very closely. Now, looking at these graphs, there's a bunch of things we can do. You can, for instance, maybe delete outliers, which is a reasonable thing to do when doing data analysis. And then the first kind of lever that we can play with is this hertz to knots. We defined electronics had a hertz to knots calibration. In fact, it reminds us what we said it was while sailing. That's not the case. You can adjust it here. And now we can try new ones. So what if I typed in 10.55 hertz for hertz to knots? So it does improve slightly our speedo upwind. It gets it closer to 0 when I compare it to my speed over ground corrected. Maybe we go one more. So that's looking pretty good. We have this summary table here of all the averages. We still do have some issues, it looks like, with these pink triangles which correspond to downwind on port, and the way we might correct that is for heel. So let's bring up the boat speed versus heel correction table. So the post-calibrated one, by default, it will have values that we had entered while sailing. So in our case, it's just all zeros at this stage. And so what are we looking for? We were looking for around 10 knots of speedo when there was close to 0 heel. So if I look at this table here, 10 knots at 5. Now the nice thing is when you click on this table, you'll see that it gets highlighted. You're seeing which point you're about to affect. So here, for instance, I might want to type this is going to be minus 0.1. Okay, so that's improved the calibration here a little bit. And then let's look at these guys. These guys definitely need to be pumped up a little bit, so probably a plus 0.2. And here we go. We've got much better numbers here. Note that in this this table here, you can actually view it as a graph, which is more common in a lot of electronics. And you can do all kinds of import, export from, say, Deckman tables or from text tables. We'll probably have a spare video just to talk about this 2D edition dialog, because it's quite powerful.